Welcome to part 2 of your review. We are going to start with number 2 in this case. So number 2 says, what is the equation of the line perpendicular to the line shown in the diagram that passes through the point -3, -5? So we are looking for something that is perpendicular. And if we recall, perpendicular means that it is a negative reciprocal slope. And for those of you that forgot what that is when you change the sign and flip. Alright, so our first matter that we should do is find the slope of this line. So we are looking for perfect points. So one perfect point would be here. Our next perfect point is until up here. So we are looking for rise over run. And because this is a positive slope, because it's heading upwards, we are going to go up first as well. So we're going to go up 1, 2, 3, 1, 2, oh, this pen is not cooperating, 3, 4, 5. So 1, 2, 3, 4, 5, 6, that's actually 6. Over our run, and that is 1, 2, 3. So if we reduce that, 6 divided by 3 is actually 2. So the slope of this line, so the slope of this equation is actually 2. However, we need the reciprocal slope. So we're looking for a perpendicular slope. We have to find the negative reciprocal. So 2 is actually 2 over 1. So we change the sign, that's positive. Let's make this a negative and then flip it. So 1 over 2. So our new slope that we are looking for is actually -1 over 2. So what we're going to do here is look at our answer choices and see which one gives us a slope of -1 over 2. So let's start off with A. So A says x plus 2y is equal to -13. X plus 2y is -13. So what we are going to do here is we're going to go ahead and subtract x from both sides because we are solving for y. So we will say 2y is equal to -x minus 13. We do have to solve for y, so I am going to divide by 2 3 times. Divide by 2 here, divide by 2 there, and divide by 2 here. This is going to cancel out. So remember, when we have a variable here by itself, it's not actually there by itself. There is an imaginary one right here. So we see that our new slope already will be -1/2. So at that point, I would say stop. We've already found our -1/2 slope. So I am just going to stop there and say A is my answer. A is my answer. So we are going to go to number 10. And number 10 is a triangle question. So it says, in the accompanying diagram, angle ACD is an exterior angle of ABC. So if we're looking for the angle, we are going to follow this order. So it says start at A, go to C, and at D. And so we are talking about this exterior angle right here. It does let us know that measure of angle A is 60, measure of angle B is 50, so we have to find this outside measure. This is our exterior angle theorem. We talked about it a little bit in our first day of review. So exterior angles, that says that the sum of the two non-adjacent interior angles has to equal that exterior angle. So in this case, we would say that the measure of angle A plus the measure of angle B has to be equal to the measure of angle ACD, which is that exterior angle. From here, we do have some pieces of information in our problem, so we would say 60 plus measure of angle B, which is 50, has to equal measure of angle ACD. When you add up these two, you get 110 degrees. That is what the measure of angle ACD is. So this would be 110 degrees. So we are going to move on to number 16. And number 16, we're going to do exactly how we did number 15. So they are asking us to find the lengths of the sides of a triangle. So which number or which set of numbers could make a triangle. So remember, the rule here is that the this is triangle inequality. Inequality. So it says the sum of any two sides has to be greater than the third side. Has to be greater than the third side. So the sum of any of those two has to be greater. So for example, in A, we have 9 plus 6. 9 plus 16 has to be greater than 20. And in this case, 9 plus 6, or 9 plus 16, my bad. So 9 plus 16 is 25, which is greater than 20. So we lucked out. Oh, my bad. We lucked out and found that A is our answer pretty quickly. These other ones wouldn't work because the sum of two sides, whichever two sides, has to be greater than the third side. So luckily 16 was pretty easy to find. Our last question is number 17. And number 17 says that we have a triangle and ACD. So ACD is an exterior angle of triangle ABC. Measure of angle B is 40, measure of angle A is 2x, and measure of angle ACD is 3x. We do have to find the value of x. So here we have the exterior angle theorem. Exterior angle theorem. And the exterior angle theorem says that the measure of A plus the measure of B, so the two interior non-adjacents, has to equal ACD. So in this case, we're going to replace the things that we know, and we know all three of these because we are looking for a value of x. So measure of angle A is 2x plus the measure of angle B, which is 40 degrees, has to equal the measure of angle ACD, which in this case, it's 3x. So what we do here is combine our like terms. I do like moving my smaller variable first, so I'm going to say minus 2x here, minus 2x there, and we are left with 40 is equal to x. So that was pretty simple. We say x is 40 degrees, and if we were to plug those in here, we would fit our exterior angle theorem.